Okay, now we're doing question 15, and we've got to find the limit of this quotient as h goes to 0 from above, so we're going to find a right-hand limit. And keep in mind, anytime you have this this format, you're going to use the difference of two squares identity, and you're going to write multiply by 1 in the form of the conjugate of the numerator. So that's going to be the square root of, and let's see, h squared plus 4h plus 5, extend that, plus the conjugate, plus root 5. So I have to write the same thing on the denominator because I can only multiply by 1, and this quotient equates to 1 because everything divides out, plus root 5. Okay, so now this equals the limit as h goes to 0 from above. And difference of two squares theorem tells us that if we find the product of these two quantities, we can simply lift the radicals off and put a negative sign right here. And so we'll have h squared plus 4h plus 5 minus 5 all over h times the square root of, this isn't going away, h squared plus 4h plus 5 plus the square root of 5. Now here the 5's add out, and as h goes to 0 from the right, from above, and we have, we'll factor the numerator with these 5's gone. We've got an h in both terms, so we can factor an h out of both terms, and we're left with h plus 4. And downstairs, we still have this factor of h and the square root of h squared plus 4h plus 5 plus the square root of 5. Now we can let oh, by the way, these h's divide out, and now we can let h go to 0. And if h goes to 0, we just have a 4 there. And if h goes to 0 here, we simply have the square root of 5 plus the square root of 5. And so what we get here is we get 4 over 2 square roots of 5, but 2 goes into 4 twice, so we get 2 over root 5. And if we were to rationalize that denominator, we would have 2 root 5 over 5. Well, now we're doing question 23. But before we do this, we want to keep in mind what's we've been told on page 89, that we're given this identity that the limit as theta goes to 0 of sine theta over theta equals 1, and we're going to employ that right now. Very important. I always want to keep that in mind. So, in other words, if we have an identical value here to there, if those are identical, then, and this is the sign of that value, then the quotient, the limit of the quotient is theta approaches 0 equals 1. Okay, we don't have identical values here, but we can remedy that. So I'm going to take the limit as y goes to 0, and now I'm going to multiply by 1. If only we had a 3y there. Well, we're going to get it. we're going to multiply by 1 in the form of 3 over 3. We can do that, and that's times the sine of 3y over 4y. Hey, all we did was multiply by 1. That's fair game. And so that equals the limit now of y, as y goes to 0, of 3 sine of 3y over, and note, multiplication is commutative, so I can switch positions of the 4 and the 3. So that's going to be 4 times 3y. Now notice right here, we're meeting this criteria. So the limit as y goes to 0 of this thing is simply going to be 1, and 1 times 3/4 is 3/4. And we are done.